Right now, as you sit there, a silent war is being waged inside your body. It's not a battle you can feel, but one shaped by every meal, every pause, and every hour between them. For most of your life, you've been taught that fuel is always your friend, that to stay healthy, you must eat often to keep the engine running. But what if that same fuel, when constantly abundant, actually causes the engine to overheat and wear down? Deep within your cells exists a built-in emergency system, one designed to conserve energy, recycle damaged components, and restore order when resources run low. This system doesn't respond to fullness, it responds to scarcity. When incoming fuel drops, a different biological program begins to emerge. Today, we're stepping inside the microscopic reality of fasting to see how your body can shift from constant storage mode into a state of repair, efficiency, and renewal. Welcome to Fat City, the metaphorical world of your metabolism. For decades, this city has lived in near constant abundance. Every hour, cargo ships arrive unloading glucose, the body's fastest, most accessible source of energy. But here is the problem. The city's wallet, the liver and muscles can only hold a limited supply of this fuel. Once that storage is full, excess glucose must be converted. Through a process called de novo lipogenesis, surplus sugar is transformed into fat. Think of glucose like loose clutter filling a room. Fat is that same clutter compressed into dense, vacuum-sealed boxes. These compact fat bricks, known as triglycerides, are shipped to long-term storage in your adipose tissue. And unlike the wallet, these storage depots can expand, sometimes by enlarging existing fat cells, sometimes by creating new ones. This is the storage paradox. Energy becomes abundant, yet increasingly inaccessible, locked away while new shipments continue to arrive. To manage this constant influx, the city's mayor, your pancreas, releases the hormone called insulin. Insulin acts like a master access card. It allows glucose to enter cells, but at the same time, it strongly suppresses access to stored fat. As long as insulin is high, the city is forbidden from touching those fat bricks. Inside the control tower, a major growth pathway called mTOR stays switched on. mTOR is the construction foreman, pushing cells to grow, build, and expand. But there's a problem. You can't deeply clean a building while the construction crew is still tearing down walls. The cleanup crews, Lysosomes, carry out a process called autophagy, which means self-eating. They recycle damaged proteins and worn-out cellular parts, but their work is suppressed during constant growth signaling. As damaged components accumulate, power plants, your mitochondria begin leaking reactive oxygen species, unstable molecules linked to oxidative stress. The city isn't just growing, it's falling behind on maintenance. Repairs are delayed, efficiency declines, and wear quietly accumulates. Then something changes. You wait or a meal is skipped and glucose and insulin levels start to drop. With less insulin signaling, access to stored fat begins to reopen. In the control tower, mTOR activity quiets and a new regulator rises, AMPK, the cell's energy sensor. AMPK shifts priorities. Growth slows. Cellular repair becomes the main focus. The city finally hauls those fat bricks back from the suburbs and melts them into a high-octane liquid called ketones. Compared to glucose, ketones can generate energy with less oxidative stress in certain cellular contexts. If glucose is like burning dirty coal, ketones are like clean natural gas. They provide the same power but leave behind almost no toxic exhaust or sparks. Suddenly, the insulin fog clears and your brain finds itself running on premium fuel. With growth signals reduced, autophagy activity increases. The cleanup crews finally get to work. They target damaged proteins, malfunctioning organelles, and cellular debris, recycling useful components and restoring order. This cleanup process influences how cells age and respond to stress, including how they handle dysfunctional or senescent-like features. Meanwhile, fasting-related signaling has been shown, especially in animal studies, to increase brain-derived neurotrophic factor, or BDNF in short, a molecule involved in learning, resilience, and neural plasticity. But here is an important point. This isn't about starving, it's about metabolic flexibility. It's your body's ability to switch between glucose and fat when needed. You don't need extreme deprivation. Sometimes extending the natural fasting period that already happens during sleep is enough to trigger meaningful changes. For many people, time-restricted eating, such as a 16-hour fasting window, can improve metabolic markers and allow fasting-associated repair pathways more time to operate. But this approach isn't universal. If you are pregnant, have a history of disordered eating, or live with type 1 diabetes, fasting should only be considered under medical supervision. The goal is a renovation, not a total blackout. We were taught to fear hunger, to see an empty stomach as a weakness. But biology tells a more nuanced story. Sometimes stepping back from constant intake allows the systems already inside you to do what they were designed to do. Because occasionally, the most powerful upgrade doesn't come from adding more, but from giving the system time to restore what's already there. As always, this video is for educational purposes only. For any health concerns, always consult your healthcare provider, and remember to stay med-curious and stay healthy. See you again next time.